So topic 9, it is on carboxylic acid and its derivative. So I put a picture of lemon over there. So do you know what kind of acid is available in lemon? Do you know what kind of acid is available in lemon?
No, sir.
No. You want to guess? At least try. Lemon is part of what we call,
Carboxylic acid, sir.
yes, carboxylic acid, but the specific acid that is present in lemon. Actually, in lemon, in lime, in orange, so all of these contain basically almost the same type of acid,
Citric acid, sir.
citric acid. So what is citric acid? Citric acid is also a type of carboxylic acid. Another type of acid that is available in all of these fruit. What do you think when you say all these, like eat orange, you can obtain a lot of vitamin what? If you want to get this kind of vitamin, you have to eat uh,
Vitamin C.
vitamin C. So vitamin C is actually ascorbic acid. It's also a type of carboxylic acid. So, but there are other fruits as well which contain vitamin C. Okay, so in this fruit, for example, you can have vitamin C, which is ascorbic acid, and also citric acid. Okay, as the name goes, citric acid, it is available in most citrus fruit. So what is citrus fruit? You have lemon, you have lime, limau, okay, and also oranges. So all those orange type fruits, okay, they may have contain citric acid as well. So what we will cover in this topic is the name, okay, nomenclature of carboxylic acid based on their structure. Okay, we will see the physical properties of carboxylic acid and their derivative. Okay, derivative is basically what are the organic compound that we can turn this carboxylic acid into. Okay, and then the reaction of carboxylic acid, such as deprotonation, esterification, reduction, and nucleophilic acid substitution. And lastly, it is on the preparation of acid halide, acid anhydride, ester, and amide. So the last part is basically the derivative of carboxylic acid, which is, you have to remember, there are only 4: acid halide, acid anhydride, esters, and also amide. So here I put a picture of a lot of other citrus fruit. Okay, so you have lemon, orange, lime. Here you have grapefruit. Okay, so these, all of these may contain ascorbic acid and also citric acid, which is an example of carboxylic acid. So carboxylic acid must contain the carboxyl group. Okay, what is this carboxyl group? So carboxyl group is basically COOH. Okay, if you want to write it, you have to write it as COOH. This is the order of writing. Okay, COOH on carbon number 1. But if you want to draw the structure, it will be actually C double bond O, okay, which is basically like the carbonyl compound of aldehydes or ketone, and it also contain a hydroxy group, which is this OH. Okay, basically it contain two. We can say that it contain two functional group in which it has this carbonyl group and also the hydroxyl group. So the name combines together become carboxyl, which is a combination of carbonyl and also hydroxyl group. So carboxyl group stands for COOH. Okay, COOH. So you can write it as this way, in which that you draw the C double bond OOH, or if you just want to write in simplified form, it will be written as COOH or CO2H. Okay, not CHOO or COHO. Okay, not that way. It must be written according to this method, which is COOH. So this is the carboxyl group, which make the organic compound a carboxylic acid. So basically, on the naming of this carboxylic acid, we will just have to change. Okay, if you have an alkane, it ends with E, but carboxylic acid will end with oic acid. Okay, OIC acid. Okay, for example, from methane, it become methanoic acid. Okay, instead of CH4, it becomes CHC double bond O, OH, methanoic acid. And then ethane become ethanoic acid, propane, propanoic acid, butane, butanoic acid. Okay, and so on. Okay, we have 7, then it will be heptanoic acid, for example. So first step in which that when you want to name a carboxylic acid, okay, you have to identify the longest chain that contains the carbon of the carboxyl group. So you have to identify which is the longest carbon chain that contains COOH. Okay, it must contain COOH because it will be labeled as carbon number 1. So here we have, for example, 1 carbon, and then you have to find out the longest chain. So 1, 2, 3, 4, or you can also go 1, 2, 3, 4. Okay, so there are 2 ways. And then replace the E of the alkane name with oic acid. So just now there are 4 carbon from butane, it become butanoic acid. Okay, butanoic acid. And then number the parent with carboxyl carbon as number 1. So this will be carbon number 1. 1, 2, 3. Okay, so at carbon number 3, okay, name and number the substituents as usual. Okay, so that means at the third carbon, there is a methyl group. So 3-methyl butanoic acid. So if it is became a substituent, it will be called as a carboxy. That means if there is another functional group which has higher priority than the carboxyl group, so that carboxyl group will be known as a carboxy. Okay, that will be known as a carboxy if it is a substituent. Then if there are more than one carboxyl group present, okay, for example, if there are 2, okay, then it will retain the name of oic acid, but the name of oic acid, you have to put di in front. So if it is 2, if there is 3 COOH, then it will be trioic acid. Okay, so note that both carboxyl group must be in the parent and location numbers need to be noted. Okay, so the parent for the aromatic, so now we are talking about aromatic, which is benzene. So the parent for the aromatic carboxylic acid is benzoic acid. So the carbon containing the carboxyl group is number 1. Okay, so an example over here, we try. So what is the IUPAC name? First, let's look at the IUPAC name. Okay, this one, forget about it for a while. So IUPAC name for this compound. So the first step goes is find the longest chain. So you have only 2 carbon over here. So 1 and 2. So 2 from ethane, it will become ethanoic acid. So then you check, is there any other substituents? If there is no other substituents, then it will remain as it is. And you have to start numbering from this COH carbon. So 1, 2. So it will be called as just ethanoic acid. Okay, common names is basically what are these acids are also known as. Okay, beside their IUPAC name. Okay, basically like, for example, ethanoic acid, it is also known as acetic acid. Okay, which is basically vinegar. Okay, the vinegar that is available at home to use for cooking. So that is acetic acid or ethanoic acid. Then for the second example over here, we have another structures. So find the longest chain. You have 1, 2, 3. From this side also 1, 2, 3. So 3 from propane to propanoic acid. Okay, and then you have to start the numbering from COOH. So 1, 2, 3. So 1, 2, 3. Then at carbon number 2, you have another substituent, okay, which is a methyl group. So 2-methyl propanoic acid. Okay, so that will be the name, 2-methyl propanoic acid. Alright, some of the properties or physical properties of carboxylic acid. So it has higher boiling point than similar alcohol. What does it mean is basically if you have a carboxylic acid and an alcohol with similar molecular weight, okay, comparable molecular weight, the carboxylic acid will have higher boiling point. Okay, this is the reason is due to the formation of a dimer. Okay, since each molecule forms two hydrogen bonds. So what does it mean is if let's say you have the same molecules of carboxylic acid, they can form two hydrogen bond at the same time, and it form this structure which is called a dimer. Okay, unlike alcohol, it can only form one hydrogen bond with the other molecules. Okay, but carboxylic acid, it can form two hydrogen bonds at the same time with another molecule of the same carboxylic acid. Okay, alcohol, only one. And in terms of solubility, okay, the structure of carboxylic acid is divided into what we call as hydrophobic and hydrophilic part. So hydrophobic is the part that will decrease solubility in water, okay, which is this R. Okay, the longer the R is carbon. If let's say you have one carbon, then the solubility will be higher. But if let's say you have 14 carbon attached to this COOH, then the solubility will be decreasing. That means you cannot dissolve it in water, for example. Okay, but this hydrophilic part, which is the OH and the C double bond O, they can form hydrogen bond with water. Okay, but it all also depends on the length of the R, which is the alkyl group. So as the size of the hydrocarbon chain increases, which is this R, relative to that of the carboxyl group, which is this one, so water solubility will decrease. Okay, so you look at the number of R over here. So lower number, the solubility will decrease with the size of R increasing. It increase with the number of carboxyl group. So let's say you have more than one carboxyl group present in the organic compound, then the uh, solubility will increase. Okay, so over here it is stated up to 4 carbon, which is the R. Acid is miscible in water. The carboxylic acid will be miscible. That means it will form a homogeneous mixture. But more than 4 carbons, it is only soluble in polar solvent such as alcohol and ether, because that way it can still form hydrogen bonds. Okay, but the longer the R group, so the solubility will start to decrease. And then we will go to the preparation of carboxylic acid. There are 6 methods in which that you can obtain carboxylic acid. One way is through the oxidation of primary alcohol, and then you have oxidation of aldehyde, and then oxidation of substituted aromatic. So that is mainly for aromatic group, aromatic compound. And then you can also do a carbonation of Grignard reagent. And then the last two will be hydrolysis of nitrile And last one is the oxidative cleavage of alkenes. So we will see one by one the synthesis of carboxylic acid. Okay, the first method is basically uh, via oxidation. So there are a few methods which have been listed just now that actually proceed via oxidation. That means you are going to oxidize a few types of organic compound to obtain the carboxylic acid, and this reaction will require the use of oxidizing agent. Okay, so the symbol is here you have in bracket, okay, the square bracket which have oxygen in the middle, and then this oxidizing agent basically you can use potassium permanganate, which is this one, KMnO4, potassium permanganate, or potassium chromate, okay, K2Cr2O7. Okay, this either one of these. You can use potassium permanganate or potassium chromate. So you can oxidize either primary alcohols, aldehydes, or also from substituted aromatics. So here, for example, from primary alcohol, okay, remember it must be primary. That means the C that is bonded to OH is only bonded to one other carbon. Okay, then it will form, this is actually RCOOH. Sorry, typo over here. We have RCOOH. Or you can also have an aldehyde. Here you have aldehyde, okay, with the use of potassium permanganate or potassium chromate to obtain carboxylic acid as well. And in the case of aromatic compound, which is benzene, but the benzene must already have substituents. Okay, let's say here you have CH3, for example. Then if you oxidize it, okay, using either one of these reagent, then you can obtain the corresponding carboxylic acid. The second, or not let's say the second, the fourth way is basically the carbonation of Grignard reagent. If you still remember in the topic of alkyl halide, there is a way in which that you can synthesize Grignard reagent. Okay, basically using alkyl halide plus uh, magnesium metal, okay, in the presence of THF or ether. Okay, then you are going to get this Grignard reagent. But once you have this Grignard reagent, okay, it is very versatile in which that you can further change it into other or convert it into any other types of organic compound, and one of it is basically carboxylic acid. Okay, and the method that is used to convert this Grignard reagent into carboxylic acid is basically carbonation. So the word carbonation is you are going to provide carbon dioxide gas. Okay, this is CO2. Just by adding CO2 to the Grignard reagent, you will be able to convert it to become a carboxylic acid. Okay, and this is the reaction pathway in which that once you have the CO2, okay, it will be added over here in which the carbon will bond with this carbon. Okay, and it will form sort of like a metal complex or magnesium complex. Okay, you have here negative charge and MgBr over here is positively charged. And then with the helps of an acid, so this is H plus, basically will comes from acid, proton. It will, okay, form a bond with this O minus over here. So hence you will get the carboxylic acid as the product. Okay, and the MgBr will be removed altogether. So basically here this side, okay, this side, okay, this from this is basically the R group. Okay, the R group. It can be any other structure than this. Okay, so it can be as simple as CH3 or it can be more complex than that. As long as it is carbon, okay, or alkyl or even an aryl group. And then we have hydrolysis of nitrile. So nitrile is basically this compound. You have R bonded to a carbon that is triple bond to nitrogen. Okay, nitrile, R bonded to carbon that is triple bonded to nitrogen. So this is nitrile. And the word hydrolysis is basically you are going to add water or react it with water. Okay, with the nitrile. Okay, then uh, it will form an amide. Okay, so it is not a single step process in which that you add, you are going to straight away get the carboxylic acid. No, okay, so it will form an amide first. Okay, first an amide and then another hydrolysis, then it will form the carboxylic ion. It will release the NH2 to become ammonia. Okay, and then uh, what you call this is also another example, acidic hydrolysis of nitrile. Okay, you have nitrile, it will become primary amide, the same. Okay, and then this one also will produce carboxylic acid. Okay, so heating with aqueous acid or base will hydrolyze nitrile to a carboxylic acid. Okay, you have to have water, but in two different environment in which that you can also add acid to it or base. Okay, this one is by adding base with water, mixing base with water, and this one acid with water. Okay, both will give you uh, carboxylic acid as the final product, but with different byproduct. Okay, with basic hydrolysis, that means you have base together with water, you are going to end up with ammonia. But acid with water, you are going to end up with ammonium ion. And the last way in which we can obtain carboxylic acid is through the oxidative cleavage of alkenes. So the word cleavage is basically we are cutting it in half. Okay, we are trying to cut the alkene structure in half on the double bond itself. Okay, so oxidative meaning it also involve oxidizing agent. Hence, you have over here KMnO4 or potassium permanganate. So basically, you have an alkene and it will be cut in half. So the product that you'll get will be something like two of the same structures. If it is symmetrical, you are going to obtain two carboxylic ion, for example. So here we said that unsubstituted alkene, which is this one, unsubstituted meaning you have CH2 on this side, you have R group, okay, unsubstituted alkene, carbon oxidized to carbon dioxide, so it will become carbon dioxide. But for mono-substituted alkenes, carbons will oxidize to become carboxylate. So the structure that you must have in order to obtain carboxylic acid is this mono-substituted alkene. Okay, because di-substituted alkene as well. So this part is considered to be di-substituted. Okay, this is unsubstituted. Unsubstituted will give you carbon dioxide, while di-substituted will give you ketone. But the product that you want to have is basically carboxylic acid, or in this case, carboxylate ion. So it must be mono-substituted. That means on the carbon-carbon bond, so the carbon, you have CH and also C, for example, in this case, CH3, or it can be any other R group. So once you have this, okay, a hydrogen atom, or sorry, hydrogen ion H plus may easily be introduced, in which that it will form a bond with this O minus. So it will be converted into a carboxylic acid instead of carboxylic ion. Now on to the reaction in which that carboxylic acid can undergoes. Um, so being an acid, so as the name goes, it is an acid. It can have a reaction of acid and base. Okay, it can have acid-base reaction, or basically neutralization reaction. So it can be neutralized by strong bases, in which this is ethanoic acid being reacted with sodium hydroxide. So sodium hydroxide is strong base, hence you are going to obtain sodium ethanoate. So basically, if you have an acid and base reaction, you are going to end up with salt and water, right? So this is basically the salt, which is sodium ethanoate plus water. Okay, so um, it can act as a base when it is being reacted with strong base. Sorry, it can act as an acid when it is being reacted with strong base, like sodium hydroxide, or you can also use potassium hydroxide (KOH), or magnesium hydroxide, which is MgOH2. All right, so you are going to end up with the corresponding salt. Then the uh, conversion into acid chloride, which is basically what we call as one of the uh, derivative, okay, of the carboxylic acid, okay, acid chloride. So there are three ways in which you can convert the structure of carboxylic acid. One is by using thionyl chloride, SOCl2, and you can also use phosphorus trichloride, PCl3, or you can also use phosphorus pentachloride. Okay, there are three reagents in which you can use to convert carboxylic acid into acid chloride, but all of them have different reaction pathway in which that the byproduct will be different. So the first example over here, if you are using thionyl chloride, which is SOCl2, okay, you just need 1 mole of the carboxylic acid and 1 mole of the thionyl chloride, SOCl2, and you are going to end up with the corresponding acid chloride. So what basically happened is this OH will be removed and it will be replaced by Cl, okay, chlorine, one of the chlorine. Okay, the OH will be removed and it will be replaced by chlorine. So that is what acid chloride is. So the OH are going to be replaced by Cl. Okay, that will be an acid chloride. So here you still get the product, acid chloride, but the byproduct will be SO2 and also HCl. If you are using PCl3 or phosphorus trichloride, okay, this reaction requires 3 moles of the starting material, okay, or any type of carboxylic acid that you are going to use. 3 moles of it will react with just 1 mole of PCl3, okay, but the product also you are going to end up with 3 moles as well, plus another different byproduct, which is H3PO3. And when you use PCl5, phosphorus pentachloride, you have RCOOH. Okay, the product is still the same. The OH will be get replaced by Cl. Okay, but in this case, the reaction only require 1 mole. Okay, 1 mole 1 mole, and the product is also 1 mole. The only difference is the byproduct, in which you are going to get POCl3 and also HCl. Okay, so these are the three ways in which you can use to convert carboxylic acid into an acid chloride, or sometimes it is also known as acyl chloride. Okay, ACYL. Okay, it may be known as acid chloride or acyl chloride. Then the conversion into ester. So ester, as what we have seen in the topic of alcohol, so you need to mix carboxylic acid and alcohol to obtain an ester. So the general formula of an ester is RC double bond OOR. So basically, the hydrogen over here are going to be replaced with the R group. Okay, so the H are going to be replaced with the R group that is from the alcohol. Okay, basically it's like they change position. R will be bonded to this oxygen, and this oxygen will be bonded to this OH to form water. Okay, to form water. So this is the general formula for an ester. You have R, C double bond O, O, R. So basically, an example over here, you just need to have uh, the corresponding carboxylic acid, and then you are going to mix it with alcohol. Okay, sometimes it also requires the presence of acid. Okay, you have H plus over here. Okay, H plus, normally you have to add sulfuric acid, H2SO4, and the reaction is actually reversible. So if you look at this arrow, one arrow, half arrow is pointing this way, and the other one is pointing back to this side, meaning this reaction is basically reversible. That means you have your starting material. Once it forms the product, this product can be turned back into this starting material. So that is what it means by the reaction being reversible. Okay, it's not one way, it is two way. Once you get to this side, you can still convert it to become the starting material back. And then we have the formation of acid anhydride, which is the third derivative of carboxylic acid. So it is done via the dehydration. So the word dehydration is basically removal of water. Okay, but the way or the reaction is basically using different type of method. So reaction of carboxylic acid with an acid chloride in the presence of pyridine. So this is the method in which you are using to convert carboxylic acid to become an acid anhydride. It is basically requires a carboxylic acid and also an acid chloride. So where are you going to obtain this acid chloride? So the acid chloride can be prepared first using this method. Okay, you have to convert the carboxylic acid into acid chloride, then only you can mix it together, okay, in the presence of pyridine to obtain an acid anhydride. So what is happening here basically is just a combination. Okay, you have two molecules over here. On one part, the hydrogen is being removed. Okay, on this side, hydrogen is being removed. You still have C double bond OO. Okay, but on one side, this chlorine will be removed. So it will be uh, attached together on this oxygen. So oxygen will form a new bond with this carbon. Hence, it will be bonded like this. Okay, acid and hydride. Okay, once you have this acid and hydride, you can actually turn it back to become carboxylic acid just by mixing with water. It will then get separated or hydrolyzed back into corresponding carboxylic acid. Okay, here an example, we have acetic acid with ethanol chloride, which is the acid chloride. Okay, once it is mixed together in the presence of pyridine, it will form an acetic anhydride, okay, or ethanoic anhydride. Okay, because both sides are having the same number of carbon. You have 1, 2, 1, 2. So the name will be called as ethanoic anhydride. So these are symmetrical starting material. But what if you are using different types of R? Over here we have acetic acid or ethanoic acid. Okay, on this side you have benzoyl chloride. So that means you have C double bond O attached to a benzene ring. So the product name will be called as acetic benzoic anhydride. That means on this side, okay, on this side it is acetic, you have 2 carbon, and on this side you have benzoic, which is C bonded to a benzene ring. And it is written as acetic benzoic and not benzoic acetic, as it follows the alphabetical order. But uh, if you are using ethanoic acid over here, then it will be benzoic ethanoic anhydride. Okay, so it is arranged according to alphabetical order. Uh, wait for a while. Okay, so carboxylic acid actually, even though it is an acid, it is still considered as weak acid. Okay, it is a weak acid, not a very strong acid like hydrochloric acid, or in fact, what they call sulfuric acid or phosphoric acid. Okay, it is just a carboxylic acid in which that when you mix it with water, okay, it will hydrolyze to form what we call as a carboxylate ion, which is this one, CH3COO minus, and the H plus will be bonded to this water molecule to become hydroxonium ion. Okay, so the form in which they exist in aqueous solution actually depends on the pH of the carboxylic acid. Okay, if you still remember in last semester you have learned in uh, pharmaceutical chemistry 1, okay, pH, to calculate pH, it is equal to negative log concentration of H plus. So that concentration of H plus is this is, okay, because the H it will get this pen, okay, it will get broken over here on this side. This one will become H plus, okay, which is basically go to the oxygen over here. Okay, thus it form the H3O plus. Okay, H3O plus. This one I think I've shown just now. Okay, back to the ester just now. Earlier is just the some of the introduction on the uh, reaction, okay, in which that it can underwent for carboxylic acid. So ester is one of the uh, derivative, okay, of carboxylic acid. Okay, basically you have the difference is on this side carboxylic acid you have H, but in an ester that H is going to be replaced by R. Okay, so it is being represented as C double bond OOR or written COR, or CO2R. Okay, this is the ester. So in an ester, the H in the carboxyl group is replaced with an alkyl group. Okay, this is the ester group in which you have C double bond O, O, CH3. Okay, or it can be written as CH3, COO, CH3. Okay, just now we have seen the reaction for carboxylic acid. Okay, with alcohol, it can form an ester. So that process is also known as Fischer esterification reaction. Okay, Fischer is actually the guy or the person who first come up with this method. Okay, to synthesize ester. So the reaction of a carboxylic acid and alcohol, okay, or phenol, okay, will produce an ester. And it also requires the use of an acid catalyst. Okay, here, as I mentioned earlier, H plus, okay, in the form of sulfuric acid, okay, H2SO4. And the reaction, as you see, is reversible. That means when you mix and carboxylic acid and alcohol, it will form the esters, and the esters may be turned back into the corresponding alcohol and carboxylic acid. So here we have an example. This is ethanoic acid. Okay, ethanoic acid are going to be mixed together with ethanol. Okay, in the presence of sulfuric acid or H plus. So this H group over here are going to be replaced with the R from the alcohol. Okay, the R from the alcohol. So this CH2, CH3 are going to be attached to this oxygen. So you are going to end up with CH3, C double bond O, O, CH2, CH3. Okay, plus water. Plus water. So where does this water comes from? One H and also one OH from the alcohol. Okay, mixed together. When they bond together, it will become H2O. So how to name these esters? Okay, it is named. There are two parts. Okay, in which you name the alkyl from the alcohol. Okay, and then only you name the acid with the C double bond O with 8. Okay, first let's see this example. Okay, the first step is to check on the R group that is coming from the alcohol. So in this structure, you have CH3, C double bond O, O, CH3. So the R that is coming from the alcohol is the CH3. So hence the name will be methyl. Okay, just like a normal alkyl group. So CH3 methyl. If there are more than one carbon, like if you have two carbons, then it will be ethyl. And then name the acid with the C double bond O with 8. So that means here you have the original of ethanoic acid, then it will be just called as ethanoate. Okay, CH3 C double bond O will be called as ethanoate. If there is 3 carbon, then it will be propanoate. And then when you want to combine the name and write it, you have to put methyl in front, ethanoate at the back. Okay, which is the R group that is coming from the alcohol will be placed in front, hence the name will be methyl ethanoate. So this is the method, okay, to name the esters. Basically the same. Okay, some esters and their name. Okay, basically esters, as you know, it gives out sweet smell. Okay, very pleasant smell. So it gives the smell of raspberries, of pineapple, and also pheromones on insects. So you can try, let's see, try to name a few of these. For raspberries, for example, you have COOH. Okay, COOH, that is the carboxylic acid part. So from one carbon, instead of metanoic acid, then it will be known as metanoate. So this part will be metanoate. And on this side, you have 1, 2, and then 3, 4 carbon on this side. So 4 from butane, it will become butyl. So butyl metanoate. And then the pineapple, okay, pineapple, you have 1, 2, 3, 4. So this will be the carboxylic acid part. Okay, so from butanoic acid, it will be called as butanoate. And from the alcohol part, which is this R group, 2 carbon, 1 and 2, from ethanol, so it become ethyl. So when you want to write it, it will become ethyl butanoate. Okay, and so on. So let's try. Give the IUPAC name of the following compound, which is responsible for the flavor and odor of pests. So first step is you check on the carboxylic acid part, which is the CH3C double bond O. So this, if you have 2 carbon from ethanoic acid, you have to convert it to ethanoate. Okay, and on the alcohol part, 3 carbon. So 3 carbon, propane to propyl. But when you want to write, this part have to be written first. So propyl ethanoate. Okay, propyl ethanoate. Okay, put a line on this side so that you know there are 2 parts of the name for ester. Okay, this one you can try. Draw the structure of the following compound. 3-bromobutanoic acid. Okay, 3-bromobutanoic acid. There are 4 carbon. For butanoic acid, you have C double bond O, OH, and then CH2, CH2, CH3. And then on the third carbon, you have bromine. And then for B, ethyl propanoate. So you have here on the CH3, CH2, C double bond O, O, and then it will be bonded with an ethyl group, OCH2, CH3. Okay, this is the answer. We have 3-bromobutanoic acid. 1, 2, 3. On the third carbon, there is bromine. Okay, and then ethyl propanoate, ethyl group on the alcohol side, CH2, CH3, and then propanoate, CH3, CH2, C double bond O, O. Or it can also be written like this. Here an example of cyclic ester. Okay, that means the structure is in a cyclic form, which are also known as lactones. Okay, they have another common names for cyclic esters. So some of the physical properties of the ester itself, it cannot form hydrogen bond to each other, but it can form hydrogen bond with water. This is why, the reason is because the hydrogen, normally in carboxylic acid, you have OH group, but in ester, it is already replaced with OR. So that OR cannot form hydrogen bond. And then the boiling points are lower than alcohols and carboxylic acid of similar molar mass, molecular weight. Okay, low molecular mass of esters are normally soluble in water, but same like carboxylic acid, the solubility will decrease as the carbon chain length increases. Okay, as long as the R group is short, it is water soluble, but as the R group on both sides becomes very long, okay, the solubility will decrease. And then it can also undergo hydrolysis. So basically hydrolysis is the opposite of the Fischer esterification. So you are what you call trying to convert the ester back to become carboxylic acid and alcohol. Okay, you just have to mix it with water. Okay, and in the presence of acid catalyst, normally sulfuric acid. Here an example, just showing. And then ester saponification. Okay, this is a very important reaction basically. So from this reaction, you can actually form soap. Okay, soap to make soap or cleaning agent. Okay, it involves the saponification process. So this is happen when you have ester, okay, react together with a base. So in this case, like sodium hydroxide, okay, it will form this salt of carboxylic acid, which can be used as a cleaning agent, okay, or basically in a lot of soap, this is one part of it. Without this, you cannot basically clean out the dirt, okay. But normally it will be mixed together with other chemicals like coloring, fragrance, okay, because this actually doesn't have any smell. In fact, the smell can be not really that good, okay, for human. So that's why you mix it together with other fragrances, so to be used. Okay, esters in plants. Okay, ester will give flowers and fruits their pleasant fragrances and flavors. So these are basically they are naturally available, okay, in plants and also in flowers. So all those good smells that you uh, see coming out from plants, okay, from flowers or from fruits, they may come from an ester, okay, which is the compound, organic compound that give out that certain kind of odor. Oh, sorry. So here, write the equation for the reaction of propanoic acid and methanol in the presence of acid catalyst. So you have here propanoic acid and methanol. Okay, when they are mixed together, it will become methyl propanoate. Okay, methyl, which is the alcohol part, and propanoate, which is coming from the propanoic acid. Okay, what are the organic products when methyl ethanoate reacts with water and acid catalyst? So here, basically, it is the hydrolysis of ester. Okay, when you have the reaction of methyl ethanoate in the presence of water and acid catalyst, it will be turned back into carboxylic acid and alcohol, which is methanol and also ethanoic acid. But when it reacts with sodium hydroxide, this is the saponification process. Okay, the answer over here in which that you are going to get, it will be turned back into methanol, but for the saponification, it will be sodium ethanoate. And then the second type of derivative is acid chloride. Okay, we have seen the synthesis just now, in which there are three methods. You can use thionyl chloride, SOCl2, or PCl3, or in fact, you can also use PCl5, okay, phosphorus trichloride or phosphorus pentachloride. So acid chloride is a derivative where the OH of the carboxyl group is replaced with the Cl, okay, with a chlorine. Okay, they are named by replacing the oic acid of the carboxylic acid with oil chloride. Okay, you have to change from OIC acid into OYL chloride. So example, preparation of carboxylic acid. Here we have ethanoic acid. Okay, you can use PCl3 or SUL3 or PCl5. So this is the product that you are going to get. CH3C double bond OCl. The OH over here are going to be replaced with the chlorine. Okay. Sorry. Yes. Then S and ester. Okay, same like an ester. The acid chloride can be converted back, okay, to carboxylic acid. Okay, this is through the reaction of hydrolysis. Just by mixing with water, okay, the acid chloride mixed with water, you can obtain the carboxylic acid back. So that means this reaction basically can become reversible. Okay, but you have to change some of the reagent. And then acid anhydride. Okay, so acid anhydride, it is a derivative where the OH of this carboxyl group, okay, the OH of the carboxyl group is replaced with OC double bond OR. Okay, O, this one C double bond OR. So two carbonyl groups are bonded to the same oxygen. So where is the carbonyl group? This is the carbonyl group. Okay, this is carbonyl group bonded to the same oxygen. Okay, this is acid anhydride. Earlier just now we have seen the synthesis of acid anhydride, in which you can have a carboxylic acid react together with acid chloride in the presence of pyridine. So the anhydrides are basically named if they are symmetrical. Name the acid minus the word acid and add anhydride. So what does it mean by symmetrical? That means both of the R groups are the same. If you have, let's say, propanoic acid, both sides having 3 carbons, then it will just be propanoic anhydride. If different groups, name the individual parent carboxylic acids in alphabetical order minus the word acid and add anhydride. This is example for number 1, in which it is asymmetrical. Okay, you have 2 carbon on this side, 2 carbon on this side. So the first example over here, this is symmetrical. So both sides are having the same number of carbon. Okay, same number of carbon. So it will be known as hexanoic anhydride, C6. Okay, all of them are having the same number of carbon. But the second example over here, you have 2 different R groups. On this side, you have 6 carbon, and on this side, only 3 carbon. So it is named as hexanoic propanoic. Why this side first and this side first? It is just following alphabetical order. Okay, hexanoic propanoic anhydride. If on this side you have 4 carbon, then it will be butanoic. So butanoic will be written first. Butanoic hexanoic anhydride. Okay, this is the preparation I have shown earlier. This one is the same. And the last derivative of carboxylic acid, which is the preparation of amide. So amide comes when you have carboxylic acid being converted into an ammonium salt, okay, which will then produces an amide upon heating. So an amide is basically when you replace the OH group with an amino group or with ammonia, NH2. So example over here, we have ethanoic acid, okay, ethanoic acid, which is going to be mixed together with ammonium carbonate. Okay, it will thus form this intermediate structure. Okay, you have CH3C double bond O ONH4. So when the reaction is complete, this reaction is complete, the mixture will be then heated and the ammonium salt, which is this one, NH4 plus, dehydrates, producing these structures of amide. So in this case, it is ethanamide. You have CH3C double bond ONH2. So the OH is going to be removed and replaced with NH2 group. So for this part, which is the preparation of amide, what you have to know is how it is being synthesized. Okay, basically you are going to mix it with ammonium carbonate. Okay, it will form this ammonium salt, which will then get dehydrated. So basically, it involves heating. So this will be further heat to obtain this amide. All right. So uh, that is the on the topic of uh, carboxylic